Our next speaker, I became affiliated with him several years back, and he brings a different idea to the topic. Actually, it's not that different. In all the speakers' comments earlier today, people have talked about economy and the finance and how we need to work together. And Dr. David Brookshire has been able to do that. And so I've asked him to come and share some of the work that he's done. But I just can't remember what he named it. There it is. Dr. David Brookshire is a distinguished professor in the Department of Economics and the director of the Science Impact Laboratory for Policy and Economics at UNM. I still don't hold that against you. After completing a BA in economics at Cal State University in San Diego, he earned a PhD here at UNM and then was on faculty at the University of Wyoming from 1976 to 1990 and came back to UNM in 1990. He specializes in environmental and resource economics, particularly public policy issues in the realm of natural resources, environmental, and natural hazard areas. His current research interests include ecosystem valuation, natural hazard issues, endangered species protection, and integrated hydrological, biological, economic modeling of alternative institutional and behavioral characteristics of water banking and leasing markets. So with that, please welcome David Brookshire.
Thank you. Hi there, a lot of you out there. It's a pleasure to be here, and thank you, Ken, for inviting me. Ken tells me that this group is made up, to some extent, of a large number of managers and people that, if you will, get out in the rivers, get out in the forest, and actually do some work. So I'd like to frame what I'm going to talk about today by saying that good policy that we all would like to contribute to fundamentally is dependent upon the integration, the coupling, the linking, whichever term you would like to use, of science models as well as behavioral models. And so in some sense, a policy decision is only as good, obviously, and I think we all know this, as the science underlying it. And as a result, I would like to talk today about an effort that a large number of us took upon, not just myself by any means, to integrate a series of models so that we could develop or contribute to the development of a decision support system tool for managing the San Pedro River in Arizona. I'd further like to take this work and extend it to some implications for the Rio Grande. My main purpose in doing this is that if you look at the first slide up here, I call this my NASCAR slide. These are all of the agencies, and I probably have left some off, that have worked at various times and done various things in the San Pedro River area. I came to the San Pedro River area approximately 13 years ago through a project at the University of Arizona, whereby we were fishing around from a National Science Foundation project called SARA to develop some interdisciplinary water science work. I realized that I was literally looking at a gold mine from a behavioral scientist point of view. I realized that there were the things that I had been looking for throughout my career, and this will become more obvious as we go through this, but basically what I learned in talking with my colleagues that I was just getting to know at that time was that there was a lot of understanding of the groundwater system, of the vegetation system, the overall riparian system, birds, etc. in the San Pedro area. So we grasped a hold of this and we put a team together, and this would be the team. And you'll notice that it includes economists, biologists, ecologists, hydrologists, facilitator, geospatial engineer, a whole group of people. And we worked together for approximately 6 years to come up with the what I'm going to share with you today. I should, of course, acknowledge that the predominant amount of this funding came from NSF, US EPA, and also the US Geological Survey. So what I'd like to do today is kind of go down this list. I'd like to talk about restoration and preservation in face of change, the need for decision support system. I doubt if I have to convince you of this, but it's worth going over. Ecosystem services, the role of science in valuing ecosystems, and what does economics in fact value. I suspect there are not too many economists out there. Finally, I'd like to talk about some of the methodologies called the contingent valuation and choice modeling. The central point here is I am not going to delve into these methodologies. I'm going to delve into what these methodologies require from the science. Then we're going to return ourselves to a discussion of a fully integrated decision support system. And then I'd like to talk about top-down, bottom-up issues or transferability issues. I believe this is especially germane given that we all are collectively hurtling toward what we now know as the cliff. And the cliff is that idea out there that somehow we're going to have to go through a series of budget cuts. Well, in fact, the truth of the matter is, even without the cliff, it is doubtful that society could afford or would choose to afford to pursue the same level of science that was pursued in San Pedro in all the river basins in the United States. So I'd like to talk to you a little bit about some of the limiting issues and how far we can take some of the work that we've done, if you will, and transfer it, that is, make it applicable to other areas in the country. So let's start in. First of all, let me ask, how many of you are familiar with the San Pedro area? That's what I figured, a good number of you. So let's do a quick run-through for those who are not. SPRINCA was formed November 18, 1988. Cattle removal from the river system again in 1988 as well. And there's a high connectivity of surface and groundwater systems. This is incredibly important to what I will ultimately be talking about. The river flows north from Canada, Mexico. It's about 40 miles in length. 56,000 acres is what the SPRINCA part is. And what attracted me to this was it was a semi-arid flyway, one of the last fully robust semi-arid flyways with 412 or so bird species, 200 plus or so are migrants. So it's a very ecologically diverse area, and the riparian vegetation ranges from cottonwood to salt cedar to mesquite to river grasses. So it's ecologically very diverse, has a large wildlife population, especially in the birds, and it is one of the few remaining flyways. So here's a picture on your left of the cattle standing in the river in 1984. And following the removal of the cattle, you can obviously see the effects around 1998. Those are the same places, all right? And this picture was provided to me by BLM and also Julie Stromberg, Arizona State University. So obviously, restoration worked. The question really is, can we just quit? And that's why we really need a decision support system, because the very nature of these systems, I think we would all agree, are constantly changing, and there's a requirement that we constantly adapt. So we need some form of an ability to track adaptive behavior. The status quo, thus, is clearly not going to be there. Here's the quick graph on the left, the change in the aquifer storage that's predicted by some of the folks at the University of Arizona, and the change in the consumptive use also. Both of these are anthropogenic changes. Unfortunately, for the SPRINCA area, it's a lovely place to live. And as a result, people want to move in, they want to drill wells, they create cones of depression, they affect the groundwater drops, it affects the vegetation, the bird abundance changes, and you get the picture. So that's really what we're going to talk about today. So why do science-based definitions, why are they important for ecosystem valuation? Now I'd like to make something really clear at the onset. Economists don't value systems, even though we talk like this. We value changes in systems, or deltas in systems. I don't know how to value a system. I don't know how to value the planet Earth, just to kind of make the point from a silly point of view. But I can give you values associated with changes in the system where the system goes from being a cottonwood system to a mesquite system. I can value changes in that. So what I'm interested in then is in understanding from the science point of view how to measure those changes through the models the scientists give me. Now this is easier said than done. All of you, how many bought something today? You're not very good for the economy. let's try that again. How many bought something today? That's much better. Okay. We're all very good at buying. We go to the supermarket, we go to Starbucks, we go somewhere. You bought your room today, all right? You might have paid for it later, what have you, but you bought something. It's almost impossible not to be in this economy. As a result, you've developed a very strong understanding of the goods and services that confront you. Unfortunately, when we turn to ecosystems, which we call in my language non-market goods, you're not as familiar in the sense of you don't go to Safeway and find on the shelf 30 miles of visibility, 50 trees, these kinds of things. And you choose between a can that holds 50 trees and a can that holds 25 trees. But when we're debating ecosystems, we have to be able to put those kind of changes in context. So, this is the wrong group to do this with, but try to do this thinking of your neighbor who does not know everything you know. Walk through the forest. They're not sitting there looking in and thinking about the nutrient loading on that tree over there and how it's coming up in some fashion. They're seeing a tree and it's green, at least in the summer, and it's pretty, all right? They see birds. And they might be a birder like I am. How many of you are LBJers? People know what that is? Come on, admit it. Little brown jobs? Yeah. All right, so the point here is you do not have, or your neighbor does not have, a well-developed sense to the same extent you do of knowing how much sodium is in that can of tomato soup you're about to buy. Right? About 720 milligrams, right? Okay? So what we need is, we need the science models to basically define some endpoints, things that we call endpoints, things that your neighbors understand. We need the science models to give us those changes, and it's then those changes that we take, in fact, to the overall evaluation process. So we're going to call these endpoint bundles, all right? And we want to understand the drivers of change that change these bundles. That is the mix of vegetation, the mix of birds, what have you. So here's a characterization of what I'm going to take us through. Up in the left-hand corner, and if you notice the boxes are kind of different colors, these boxes are going to appear in the slides as we go through this, so you have some idea where we are. First of all, we need to talk a little bit about the characterization of the ecosystem, its components, its processes, its outputs. We need to develop scenarios. In this case, the driver of change in the San Pedro is changes in groundwater levels. That is the predominant driver reflecting the health of the San Pedro system. We're going to then kind of flip over to the DSS. We're going to generate out of that changes in the hydrology component. And notice this word change or delta is beginning to appear. Changes in the riparian component. Changes in the avian component. And finally, this forms, these sets of changes, from some baseline to some change, forms this bundle of attributes, much like the 8th aisle in the Smiths as what? Tomato paste, spaghetti sauce, and noodles. All right? So it defines that kind of framework that you're dealing with. So let's talk about the characterization of what I need as an economist doing these kinds of studies. First of all, I need to understand the components of the place, the trees, the birds. This is very straightforward. I need to understand the ecosystem processes and functions, both biological, chemical, and the physical interactions. Why? Well, you'll see in a moment, somehow I've got to figure out how to take that from my science friends, translate it into something so people understand these processes. That is, they get it. They understand what I'm talking to them about when I talk about these changes. This process then defines these endpoints of the place. And these endpoints are things that are directly related to human welfare measures. Okay? Now, if you sort of did a Venn diagram in your head, I'm sure this group could easily say ecosystem services, and they'll talk about all the linkages between water and trees, and we heard earlier about the effect of fire and all this. Take that Venn diagram in your head and then just take a small piece out of that thing. Just a little tiny slice, kind of like a little peach slice there. That little peach slice is the kinds of things that your neighbors get. All right, they understand changes in the vegetation patterns going from, at a gross level, from cottonwoods to mesquite. They understand the change in abundance birds when you go from high canopy to shrub birds, these kinds of things. So I need those endpoints and I need those attributes in a way that my neighbors get them, okay? Now, what are some alternatives for the San Pedro area? And this is a very, very simplistic slide, and I will grant you that, but I just want to drive home the point. With the anthropogenic changes that we talked about earlier, clearly this area, you're going to do a couple things. You're either going to move people out, that sounds realistic. You're going to close the military base, that sounds realistic. You're going to conserve water as much as you can. You're going to be as efficient as you can. Bottom line, people coming in requires water. Water comes from wells in that area. Wells go down, and the groundwater system decays. Okay? So we can have infrastructure changes where we address the location of subdivisions based on the hydrology of the region. We know some areas would be better to put in wells than other areas. We can define recharge basins that are doing some of this. We can bring water to the basin. People talk about bringing tap water down I-10 and doing various things with it. We can do water conservation. Probably all of these will happen, including pricing. The bottom line, though, is probably if you're going to maintain this system, you're probably going to have to do something. Now, when we did this study, a little bit of a side note, we really weren't as far along in understanding the potential climatic changes to the San Pedro Basin as we are now, as I understand it. This story is actually even worse than I'm going to make it, because as I understand it from my colleagues, that in fact the mountain front recharge that's going to be associated with the mountains there is in fact going to be, let us just say, growingly insufficient. Okay? So here's a quick look at, I'm going to call it a standard DSS. And the reason I'm going to call it a standard DSS is because it has no behavioral component. Behavioral components are important because if we're really going to balance the use of society's resources and decide how we're going to spend our money, we need to know how people place value on different kinds of things. Typically, the marketplace does that. We know what people place in terms of value on tomato paste. All right, so the DSS that was developed by folks in Arizona incorporates the USGS groundwater model, surface, has a little bit of market water uses, but it's missing the non-market values. And so the first thing we want to do is develop a series of scenarios. And on the right hand, obviously, you can see a simple graphic of types of cones of depression. All right? So the kinds of scenarios that we might develop are, we have a uniform decline in the groundwater system in the basin, we have continued and increased agricultural pumping, etc. And so focus on the bottom two, because what we did in the study was we bookended the scenarios. Dry it up, turn it into Little Ireland. That's basically the two things that happen. And everything else that you can't read, I'm sure, in the back row, Groundwater Future 1 down through Groundwater Future 7, is a combination of various things. But we're looking for these bookends as framing the overall problem because we're trying to develop a tool. As I said, policy models need, policy decisions need good tools, is to essentially what the bookends are. Now, we call these little Italies, all right? This is the shape of Springa, the San Pedro area. Take your eyes, if you would please, to S8 and S9 on the right-hand side. Those are the two that I just had up on the last slide. The river is completely dried up. Basically, you just have straight mesquite up and down the river. S9 would be what I call Little Ireland. Is it really viable? Well, that'd be an awful lot of CAP water coming down that I-10. But we're really interested in the various mixes in between. So let's turn to the riparian model. And so notice up in the left-hand corner, we're talking about changes in riparian component, all right? This work was mostly done by the direction of Julie Stromberg at Arizona State University and many graduate students, where basically they based what they thought the deltas would be to changes in the hydrology using non-bio indicators, okay? They defined then, in an aggregation sense, current conditions and then different levels of ecosystem functional capacity. And they tracked these changes. So they really took some very detailed information and they aggregated it up so that they said that roughly dry is where there's 73% tamarisk, 10% cottonwood. Intermediate is 20% tamarisk, 63% cottonwood. Wet is no tamarisk, 89% cottonwood. In other words, the groundwater system, depending on where it is, supports these three, what we now call condition classes. And you can see a picture up there on pictures on the right-hand side. You then couple that, all right, we've got our changes in groundwater, and we know as the groundwater moves, we know how our condition classes move. We're now interested in how, if you will, the abundance of birds change. We didn't deal with diversity, because Area and Brand, who did this work, said let's just stay away from diversity. Probably the issue centrally is abundance. Very simple graphic. As you move to the right on the horizontal graph there, declining groundwater scenarios, you have drops in abundance. Now obviously this is very aggregated, but it gives you an idea of the coupling nature. So again, to keep track of where we are, it changes the groundwater, it changes the riparian system, it changes the abundance of birds. All right, so I'm beginning to get a capability to generate those deltas that I talked about. So let's turn now, what will we do with this? Well, there's a literature out there, it's called non-market valuation, developed by economists, psychologists, and others, and scientists, that in some sense its roots begin in 1963 in a Natural Resources Journal by Robert Davis. It's embodied in various federal documents. I won't tell you that the methodology is not at times controversial, but unless you have, 5 or 7 months for me to take you through all of the literature, I will share with you that in fact, we're feeling pretty confident in certain kinds of situations that this methodology produces dollar values which are usable in benefit cost frameworks and can be introduced into a DSS. So at a very gross level, one is a contingent valuation model. It asks individuals their willingness to pay. You express your willingness to pay when you go to Smith's and buy that tomato sauce. So our job is to develop a framework that is similar to your shopping every day at the store. The other is what we call choice modeling, where rather than choosing over one attribute, you're choosing over a bundle of attributes as I talked. One of the ways you do this is you have to, in some sense, develop the market, if you will, and imagine quotes around that market in your mind. That is, you have developed a tremendous amount of understanding as you shop on a day-to-day basis, as you click through Amazon.com to buy something. So one of the ways to develop this market and inform people is to have a very detailed description. Think back to what I said, where I've got to be able to explain this to the folks as to what's going on. I got to have them understand. You change the groundwater, you change the trees, you change the birds, etc. All right? So one way you do this is you form focus groups. I suspect a lot of you have been part of something like this at various points in time. You go through and you have them tell you, in fact, what they understand, what they don't understand, and they often tell you there's too much information here, but they want to know about this too. And so you're always presented a dilemma. It's a very difficult process to try to get down to what they get. We took these folks through a focus group. So again, I want to emphasize, and I put this slide in to remind you that we don't value systems, we value changes. So we're getting the marginal dollar value generated by the contingent valuation or the choice model in terms of these endpoints, or that little tiny slice of your Venn diagram you're still holding in your head, okay? In this case, we're taking incremental changes in miles of surface water, breeding birds by nest height, breeding birds by surface, water dependency, spring migratory birds, and vegetation diversity. The graphic on the right probably is not big enough for this room, and my apologies, but basically, this is some of the graphics we presented people in the sense of this is the current conditions. At the top it says miles of current surface water, migratory birds, the breakdown by nest height of birds, the breakdown by water dependency, sections of the river dry. So the survey in and of itself, which is done online and by mail, includes a discussion of the riparian zones and focus on groundwater. One of the interesting things that we did in this was we ran, if you will, 2 focus groups. We ran the general population focus group, but the scientists on the team would not let me change things if I was beginning to make it inaccurate from a science point of view. All right? This is a very arduous process. Working across 2 groups for a constant. Imagine 20 sets of track change documents. And you begin to get the picture with every document being a little bit different. Okay? So, this essentially makes up the market information. The graphic of how it works is people are asked willing to pay. You work down a chain versus yes or no. You record these. Again, as I said, this is either a paper survey that we mail to people. We mailed out over 20,000 surveys, or it's on the internet, and they actually can log on and take the survey on the internet. So what we're interested in, just as a slice of the results, is the willingness to pay to attain a change from concurrent conditions. Think of this as an improvement in the river, or more little segments or reaches, if you will, of Little Ireland, all right? And so, basically, on the left-hand side up there, you have the current conditions, and then the groundwater future 6. Now, there's a lot of language that goes around this that I can't put up on the slide, but that's a choice. This or this. Think of it when you go to the eye doctor. Better, worse. Better, worse. Right? Choose. And that's what we're asking them to do. So it's a process that everybody is really quite familiar with. These are preliminary results. What I want to share with you is that these are the kinds of things that explain the values that people place. Their education level, their income level. They like ducks a lot. All right, male, female, these kinds of things. So this is a normal econometric, independent, dependent relationship that we got. And the values here are not especially important. But if you want to look at the mean values, they're ranging around, the upper bound is 100, and the lower bound is 40, okay, for these deltas or these changes. What we then do is notice there's a new red arrow kind of squiggling back to the DSS. Effectively, what we have derived here is a demand function for these attributes, just like we have a demand function for tomato paste and tomato sauce. We reintroduce that into the DSS, and you can rerun this DSS and get trade-offs associated with the values and how people want to see the river change. It will give you an idea of, let's say, how big is that pipe coming down I-10, okay? So before going on and getting to these transferability issues, that one of my arguments is that it's fine to get to restoration. And this is clearly not my argument. I've been listening to a lot of folks. Preservation is going to require the ability to have this adaptive process. And that's why these tools are probably so important. If you do couple up these science models and ecosystem models, and if you've lost the thread, remember that the changes then that we're valuing are changes then that the scientists can model. And that's especially important. These are real things that can happen according to these models. All right? I would argue that you want place-based ecosystem attribute values be benchmarked in a particular place. And that's where I'm going to jump off now to transferability, upland issues, and integrating some of this information. So there's a group of us that has kind of gotten together. We have this thing called AGAVES. The Assessment of Goods, Evaluation of Ecosystem Services. It's a group that just basically gets on the phone once a month. It's a large conference call. We're all pursuing our independent research. But we're asking certain questions, and we're hoping to bring this research together. First of all, can you transfer the science? One of the interesting things in this project is, and I'm about to just talk a little bit about it, is we also did work in the Rio Grande. But the Rio Grande, even though it's been studied, was not quite the gold mine that San Pedro was, in the sense of the models and how they've been put together. So as a result, there was a lot of issues associated with, can we even move the science from the San Pedro to the Rio Grande? And I can guarantee you there was a lot of consternation amongst the scientists about whether we should do this at all. Now, to my neighbor, what's the problem? There's a cottonwood, there's some mesquite, there's some birds, but the scientists obviously had trouble with this, okay? And so that's one thing that we want to look at is horizontal transferability between systems. How similar do these systems have to be? The implication is then, can we take the values we have and also transfer them? So there's two transferability issues. Can the science models move across, and can the valuation models move across as well? All right? A second issue that we're working on is the boundaries of a region. We're talking the Southwest, we're talking the West, and I'll expand upon this. And finally, we're working on trying to get out of strictly field work and link up remote sensing, and some interesting work at USGS has recently been done on satellites and linking it to crop patterns to nitrate contamination of groundwater systems. If we can do that, I've got my delta. And we can begin to even form, for instance, a market for nitrate trading in Iowa and Ohio. Okay, so what's the research question? Can we have a national value? This slide comes from my interactions with people in Washington. And I don't say that with a lot of warm heart here. They always want a number. They don't want numbers. They want a number. They want a national value. I'm going to suggest to you this is really a bad idea. Okay? And I don't think I have to convince this group, but I'm going to go through it anyway. All right? There are these top-down models. That is, these open, they're not open source. Some of them are black box models that say you could take this particular software and you could drop it in somewhere. The National Capital Model is a good example. And you could somehow come up with values. I would argue you don't use those models because the underlying structural information, the equations, the science, etc., has assumed transferability across the nation as a whole. And I don't think that's acceptable, both from an economics point of view or a science point of view. So let's do bottom up. All right, so my idea is, again, you do place-based economic valuations and you work with the science in terms of how far you can bring this up. The bottom up probably reduces uncertainty because we can track it. It reduces uncertainty of the ecosystem values. It's more costly to approach and approximate. It clearly takes longer, requires more field work, but it probably generates a better set of values for policy purposes, okay? So one of the things we did in this study, and I am watching my time, Ken, is that we replicated the San Pedro study in the Rio Grande, right down here, the Rio Grande State Park. We did surveys, we did the whole bit all over again. What we're going to basically do is look at that old Latin square. We're going to take values from San Pedro and apply them to Rio Grande. But we've got actual original values in Rio Grande, and we can compare those two. We can take values in Rio Grande and apply them to San Pedro. But we've got actual San Pedro values, so we can compare them. So we can fill out the Latin square. We can basically come up with a calibration form that allows us to then say, is this transferability? The next step is, and these are some of the results in their preliminary, and I'm going to skip over these are box and whiskers, and there appears to be some consistency in this Latin square I just formed. Now I want to extend it to the salt, to the halide. That's what mine says too. Okay? Actually, mine says 8 minutes. And I'm on Verizon time. What are you on? You on AT&T or something? Anyway, I'll finish up here in a minute. Thank you for your patience. So now we want to move the transferability from the Rio Grande and San Pedro. Remember, as we're doing this, we're asking the question both the science model side as well as the valuation side. We're not just picking these values up. This is a really important thing. Can we take this across various river systems in the Southwest? Okay, let's go to Hawaii. Does that make sense? Obviously not. So the point here is there's going to be limits. So the best you're going to get out of this kind of work, if you buy my bottom-up approach for a national value, is what NPR calls Patchwork America. You're going to do this by region, by region, by region, depending on what those regions are, and you're going to build up these values. But the truth of the matter is, and I would suggest that asking about a national value is really just kind of a crazy question. The policies are very much at the local, maybe the regional level. What they're doing about water supply in Georgia, as Atlanta pulls all the water out of the river there, which I will not try to pronounce, is quite different than what's happening in New Mexico. So, again, how far can we carry the aggregation? I would suggest we need to be very careful with this. It violates the principles of how you aggregate up science models and whether models apply across different regions. And it certainly, from my point of view, violates economic models and the aggregation. So, I'm going to say thank you very much for your time, and I hope you enjoy your lunch.
Any questions for Dan?
How do you decide when you have different values from one area to the other?
I'm sorry? Do it again.
Yeah, how do you decide when you have different values from one area to the other that these are too far different to be transferable? Is there a rule of thumb that you use there, or you know what I'm saying?
Yeah, I avoid rules of thumb.
Okay.
We haven't gotten to the point, these are going to be kinds of questions that you've got to answer. And really the answer is going to lie in the uncertainty of the measurement and whether you can live with that uncertainty associated with policy decision. Right? I mean, if you just need a number, take one from Hawaii. And people do this. All right? But if you really need a number that's going to be relatively more precise, have less uncertainty, variance, et cetera, around it, then probably there's it. So it's going to be some kind of statistical decision. It's much like in the endangered species work, what's really an impact on the economy? And we did some early work way back in the early 90s, and we noticed that, GDP bounces up, and our error terms were inside that GDP. Well, does that mean that impacts the economy? Those are hard questions, but that's what we're working toward. I suggest you will, my favorite phrase in my classes is, it depends. It depends on the context and the circumstances. It's a very real question. So that's a good non-answer, right?
I got a
Sure.
So looking at the maps of the study, the headwaters of this river start in Mexico.
Then Mexico, right?
And
Just over the range and the world's largest, second largest, I think, is Papua.
okay. And did your science and your research, did it start in the United States?
Yes.
Okay, that was my question. How could you justify, I'm not questioning your work or anything, but how can you justify your science or research if you didn't take into consideration the whole river itself? Especially the important areas, which would be to me, the headwaters, where that shouldn't start.
So the question is, how do I justify doing this when I didn't pay any attention to Mexico? Is that fair?
And those activities that are
All right.
associated with
The science answer to the question that I received from the hydrologists is that the aquifer system, roughly in the Mexico area, which serves as the pumping grounds, if you will, for the Cananea mine, where they take the water back over the ridge and dump it in, and then it goes into another basin, is a different aquifer system than the one we're dealing with. So basically, there are two systems, two aquifer systems, and we can bifurcate it on that basis. The second reason is a lot more pragmatic. The Mexicans haven't funded this kind of work. On the science side, we don't know what's over there. All right, so there's not much we can do. But I'm after changes in ecosystem attributes
I would make a sprinkler. So again, that's a nice non-answer. I'm good at this, I teach. It's a good question. We had to narrow the scope. Okay. That's a good question I can answer.
What's the final utility of developing the buildings pay in implementing management? Or coming up with that value, does that involve taxing for restoration?
Sure. The question is, what's the value of having these values, if you will? And I'll take you simply to a framework which you may love or hate, doesn't really matter, but sometimes decisions are predicated in part on benefit cost analysis. This gives us the benefit side. All right? And so we can then take that benefit side, because we have a demand curve for market goods, we have a demand curve for non-market goods, it goes into the benefit side. And the simple benefit cost analysis is the benefits to whomever they accrue and the cost of whoever accrues. So it allows me to do a trade-off in the benefit cost of those various, let's say, infrastructure options. Right? Without those, I can only look at a cost minimization framework. Right? What's the least cost option? Which might not be the best option for society because it's really not an allocated decision process. Right? It's a good question, but that's why we do this. Right? And eventually, when we get these values introduced, as I said, we'll run those values in that sense. Okay? See, I can answer this.
Thank you, David. I'd like everybody to give another round of applause for our speakers today. The theme was ecological thresholds, and we heard about thresholds, whether we're at them, across them, falling off the cliff. We'll have to figure out, depending on the area that we're working on. I guess it goes back to, it depends on what you're looking at. But the question I kind of want to leave you guys with today is kind of ties into all this stuff. Fire, water, climate, and it ends up with basically David's talk. What are we as society willing to pay? And that's what we as managers and researchers have to work with. So with that, we'll close the plenary, and we'll have talks starting at 1:30. If you signed up for the student mentor lunch, that's going to be in the serenade room. And then I want to encourage you to continue to buy those raffle tickets. Thank you.